Hello, my name is Eshel Peleg, and my research focuses on understanding how harmful bacteria are transported and deposited in streams. So pathogens in freshwater systems pose significant health risk. Many people rely on streams and rivers globally for drinking, irrigation, and recreational activities. Anthropogenic activity leads, in many cases, to contamination of these water bodies by chemicals and pathogens. Communities that rely on untreated water sources face heightened risk of pathogen exposure, which can lead to a variety of health issues, including gastrointestinal disease, skin infections, or more severe conditions depending on the specific pathogens. In my research, I use E. coli as a model bacteria to represent pathogens. So my research has two main objectives. The first one is to understand how E. coli levels change over time and across different locations in a Mediterranean stream. And the second is to study how the interaction between water flow and suspended sediment particles impact the transport and deposition of E. coli. So these objectives aim to bridge the gap between what we know about water contamination and how we need to manage it better. I used two approaches to study E. coli. The first one is fieldwork in the Meshushim and Yehudia streams in the Golan Heights, where I sample water and sediment over a year to capture seasonal changes. You can see here the Meshushim catchment map. The second one is control experiments in a lab flume, which is basically it's a simulated stream. Here I add E. coli and sediments to observe how flow speed and sediment size affect where and how much bacteria settle. So this combination of real-world and experimental data gives us a comprehensive view of how E. coli behaves. So here's what I found so far. In the water column, E. coli levels are higher during the warmer months. And in the sediment, the opposite is happening, and there's a decrease during the warm season. So this tells us that there is a correlation between E. coli in the water column and the stream sediment. So why this research is important? First of all, is to enhance understanding of bacterial pathogens distribution in streams. It will refine models for predicting pathogen transport during base flow and events like spills or storms. This research will also help develop strategies to protect public health and ensure water safety for drinking, recreation, and irrigation. Thank you very much.